Okay, the next practical experiment, that is your center tap. Now you're using a center tap transformer. Remember, our transformer, as it is in the lab, it is of a center tap. Now with this center tap, simply like I have already explained previously, you will see that you have got there, there, and there. That is how you find it in the lab, which means that is positive, negative, positive there. Now, with this, it simply means that in one transformer, now you are sharing the voltage. When you share the voltage, which means from here to here, you're going to get 6,3. From here to here, you're going to get 6,3. When you add the two, then they will give you 12,6 volt. That is your AC voltage on the secondary side. This is where your center tap is. Now, be very careful or be very understanding. Now, this ground that you see here and that ground that you see here, it is common. It simply means that they are internally connected. But on the circuit, you can connect this in the air and connect this in the air, and then you think that they are connected. No, you need to make sure that at the end there is a wire that connects between this point and that point there, so that at the end of the day, you're going to have an internal connection. Or else we can just dotted this in this way just to show you that that is how it is connected. Remember when it was explained thoroughly in class, or it was explained during theory period, it was explained that the current, when it moves, it must make sure that it moves half of this going in that direction. Because of this positive cycle, then it's going to go like this and it goes there. Then the other half will go in this direction due to positive negative there, then you will see that it's going to go in that direction there, which means these two, they will be generating, also they will be conducting at the same time but with different cycles. They will be conducting at the same time but with different cycles, which means when you what you see here, you're going to see half of the cycle, and also what you see there, you're going to see half of the cycle. That's why when you measure here, or when you look into the your metal configuration here, it becomes your V secondary divided by 2. Also here, V secondary divided by 2. That is your center tap transform. Now, already from the previous explanation, we know what is this, which is your diode. And we know what is this, which is your resistor. Now, again, the piece of cardboard that I have so that I can use this. Again, the lab. The lab, 1, 2, 3. This is what you find in the lab. Then you have got positive there, negative there, positive there. This is what you find in the lab. Therefore, then from there, then you have got your circuit, which means you've got a wire that is coming to connect there. Hole, then you have got your component, then you have got the hole. Now, then again, you have got hole, sorry, wire, you have got there, component, connected there. Now, again, please, people, make sure that what you do, or when you do this, make sure that you do it thoroughly, small, nicely, so that it can fit within your board. But for the purpose of demonstration, I just have to draw it in such a way that it is visible for everyone to see. Then from there, then you take your diode. Again, with your diode, remember it has got the positive side and you've got the negative side. One diode will be placed there, and then the other diode will also be placed there. One diode will be placed there, the other diode will be placed there. Then from there, before you even do anything, then I must make sure that this side and also that side, they are connected to a resistor. It's either I can extend with a wire and connect the two. Then I drill a hole there, or I punch a hole there so that I can insert my resistor. I punch a hole there so that I can insert my resistor. That is my resistor there. Then I will say, now I need to have my resistor. I need to have my resistor there. That is my resistor. Then the other side of the resistor The other side of the resistor, remember you're punching holes. Now, with this punching of holes, it's simple. You can take something like a pin, like this. If you've got pin, this is the pin that I'm talking about. You can take a pin, something like this, and then you just go to your board, like this, and then you punch a hole. Then the hole will be visible on the other side. And then on the other side underneath, you just put your wires so that, but make sure that your wires, they don't combine together so that they create a short circuit within your circuit. Now, this connection that you do here, it must be the same connection that you see underneath. Now, with this, that is your circuit. Then from there, then this side, it cannot be left hanging. Then I will have to say, now I need to extend this wire. I need to extend this wire from this leg. I need to extend it and make sure that I connect it there. I hope you do understand what I have done. I need to connect, make sure that I connect it there. Then you have designed your center tap circuit. Now with this center tap circuit, then from there, you take your measurement between this point and that point. That's where you're going to find your output. Here and here, you measure the output without the capacitor. And you know that with center tap, your output waveform, it is going to be in this manner. That is where you're going to find your output waveform. Now, this is the output waveform without the capacitor. This is the output waveform without the capacitor. Now, then from there, if I include the capacitor, which is your capacitor, if I include this capacitor, remember capacitor polarity, longer leg, shorter leg, then I say this capacitor, I'm going to punch a hole here, punch a hole here, so that I make sure that the connection is correct. I make sure that this wire can conduct here and here at the same time, and also can conduct there, and also can conduct there. Then this side, I make sure that these two pins are connected. They are conducting wire. They are conducting these two pins. Then I must connect them to ground. Then you have created your circuit there. Then from there, you will see that once the capacitor it is being connected, then the output is going to be different. Then you will see that now you will have conducting, or you will have your output in that manner there. Then you do your circuit. Now, if you go to the page of the experiment, if you go to the page of the experiment and we scroll down, this is your center tap. This is your center tap. Sorry, yes. Where is it? Where is it? That is your center tap, which is this one here. That is the circuit that I am talking about. Now you'll see that with this center tap there, you're going to get, or here, that is half of the circle. That is half of the cycle that you're going to measure. Then from there, this becomes your output. That is half of the cycle that you're going to measure. This becomes your output. Now, then it says note ground position. Always note ground position. Now, if you measure from here to here, you're going to measure the same as measuring from there to there. Then you'll see that when you do your output, you're going to draw the output there, whereby in this case, not capacitor connected, not capacitor connected. Now, once you connect the capacitor, like I have shown you there, once you connect the capacitor, you will see that now it's going to have a ripple voltage. Now, then it says, now you add the capacitor in parallel with the load, measure V out DC and peak to peak ripple voltage and ripple frequency as before. So which means you're going to measure what will be your ripple frequency that you generate from the oscilloscope that you see there. With your oscilloscope that you see there. That is your half wave rectifier. That is your half wave. So that is your center tap. That is your center tap. Then we come to this one here, which is your full wave rectifier. Then we come to that one, which is your full wave rectifier. Now let me get a new clean board so that we do a full wave rectifier. Full wave rectifier. Now, with this one here, then you will see that when I do a full wave rectifier will be done in this manner. A full wave rectifier will be done in this manner. Already you can see there on the screen, I've shown you what is a full wave rectifier. on the screen, I showed you what is a full wave rectifier. So there's no need for me to redraw it down because already you can see there what is a full wave rectifier. Now, this ground that you see here and that ground that you see there, it is connected, they're internal connected. But now, how they represent it schematically, it is not how it's supposed to be done. You can't connect this in air, connect this in air, and then you think they are connected just because symbolically they are ground symbols. You must make sure that there is a wire that is extended up to there, there is a wire that is extended up to there, so that at the end of the day, you have got your a connection that exists. Now, with the full wave rectifier, if I go back, with the full wave rectifier, with the full wave rectifier, then you will see that, let me see, I think this is going to be, yeah, let me see. Now, with the full wave rectifier, this is what I'm going to do. Now, I need to make sure that, again, at the lab, this is what I find at the lab. Positive, negative, positive there. But I'm going to use this one and that one there because this is for center tape. Now, I must make sure that this belongs to the lab there already. It is at the lab, which means my circuit, as I've already explained, needs to start from outside the lab so that when I come to the lab, then I will find these ones here. Then if I want to build a bridge rectifier, now with the bridge rectifier simply means that now I will go and say, let me construct this bridge. How do I construct this bridge? I will say at this point here, I will have to have this point. I will have to have a diode that I say, this is my diode, punch a hole there, punch a hole. This dot that you see, it's a punch a hole. You're punching a hole so that they can be, your components doesn't fall out or move around and so on and so forth. But you must make sure that you connect them underneath by a wire so that at least they stay within your board. Then again, I've got that one there, punch a hole there. From this hole, I have another one there, punch a hole. From this hole, I have another one there, then punch a hole, which means now I have punched 4 holes so that I can insert my device. Now, this thing is very important. You need to go and check. Oh, negative there, I'm fine. Negative there, I'm fine. Negative there, I'm fine. And also negative there, I'm fine. Now, then from there, then if I place my capacity, so if I place my diode, you'll see that one diode sits like this. Then the other diode sits like this. Then looks like I've lost my diode now. Oh, one diode, yeah. Then the other diode sits like this. Then the other diode also sits like this. Then you've created your bridge rectifier. As simple as that, you've created your bridge rectifier, which means now I know that these two are connected together, these two are connected together, also these two and that two are connected together. Remember, you are punching holes. Now, then I'll go and say, now I need to check what is the connection there. Then the wire from here must come and join there. The wire from here must come and join there. Those are the 2 wires that I have come and joined. Now, if you go back to your circuit so that you can see clearly from the bottom, you will see that that wire that I was talking about from the transformer goes there. The other side from the transformer, it goes there. If you go and relate the two, let's see if you can be able to relate the two, if it's possible. Yeah. I hope it's going to be more or less possible like in that way. Can you see that here? One wire is there from the transformer, which is your transformer, that side, it goes there. One wire on the other side of the transformer, also it goes there. Remember, this is a bridge rectifier. It differs from the center tape rectifier because with the center tape you use the middle one. This one we are not using the middle one, which means one wire goes there, also another wire goes there. Then we need to have this connection here, which means from this connection it must go to the negative side, and also this connection must go to the negative side, which means it must be grounded. It must be grounded. Make sure that it is being grounded. Sorry about that. It must be grounded. Now, when I ground this, then I will say, uh, when I ground this, then I will say, sorry about that. Then I'll say, I need to make sure that this connection and that connection, they are connected together. Now, with that connection, which means now I must go to here and say this one here must go there, and also this one must go there, which means this is a wire and also that is a wire. But now, don't forget, you have got what? You have got the resistor there, which means I go and put a resistor there, which is my resistor without polarity. That is the resistor without polarity. That is the resistor. Okay. Then I've punched a hole there, inserted the resistor, also punched a hole there and inserted a resistor. Now, here, this is a wire conducting. That is a wire also conducting. Then this is the component, the resistor, and also that is a component which is, sorry, yeah, that is a resistor there. That is a resistor. This is a wire. That is a wire, punch hole, punch hole. Then from there, then here you take your measurement. Then here you take your measurement. When you take your measurement, then you're going to say, now I need to find out exactly what is my output. Then with your output, according to a full wave rectifier, as already we have discussed this in class. What is happening here? Why doesn't want to return? Now my page doesn't want to return back. Okay. Okay. Now, if you scroll down with this, that is the bridge rectifier. Then you will see that here you must determine what is the V out. V secondary, you know V secondary, where you measure V secondary between the 2 points there on your transformer, which is the secondary side. Then we need it in RMS, V secondary RMS. Then that is the measured value. You go take your oscilloscope, so you take your multimeter, you measure there, you find the value, then captured value, computed value, and then you have got your measured value. What is your measured peak value? Now you are displaying this within the oscilloscope, because there is your oscilloscope is given there, whereby you can take your readings. Then without the capacitor, then you go and include the capacitor. When you include the capacitor, now you will say, here's my capacitor. I must make here on that wire. I drill, which means now I go and include my capacitor. When I longer leg, shorter leg. Don't forget, longer leg, shorter leg. There I put my capacitor. There, longer leg, shorter leg. Then I have my full circuit. Then now you're designing yourself a full bridge rectifier or a bridge rectifier. Desired output, you will see that with your capacitor desired output there, it is going to be your output without the capacitor. Once you include the capacitor, you will see that that will be a ripple voltage output. Then you take this, you design it at home, fully designed. Make sure, now verify, you must make sure that you verify, or you can come to me and say, but say, we have done this, is it correct? Does it look fine to you? Does it look correct? Then I can retake it for you. And or when you get to the lab, you ask the technician, this is what I've designed, do you think, is there any short circuit? If he asks you questions whereby those are fault finding questions, where it says, now, do you think this will help if these two wires are connected, or if we have got a short circuit of wires that is existing within your circuit? Now, once you take the measurement, once you take everything, then you take your student card for all of these circuits that you're building at home. You write your, on the cardboard that you're using, you write your information, student number, initial, surname. Then you take your student card. Next to it, this must correlate. Then you take a photo in the lab, not at home, in the lab, and also you take a photo of the oscilloscope with the measurement that they are looking for. If it's a waveform, you must take a photo of the waveform, and if it is measured, you must take a photo of anything that you're measuring, a photo, then you upload your photo together with your report so that when you answer those questions, you know you're answering based on what is needed. Then if we go back to our experiment, that is the last experiment on the rectifier. Then we scroll down, it says draw the conclusion. Then you review or evaluation on review questions. You answer the questions according to what has been asked. Then there is another question there that they're asking with regard to the center tape of the transformer. Then you go back to your cardboard. Remember, you can do this by cutting your cardboard differently. You can do this by cutting your cardboard differently. When you cut your cardboard differently, what does it mean? It simply means that you can have 3 cardboards that has got this circuit, as I have shown you. You can have 3 of these cardboards, which means now I can say this is the cardboard that has got a full wave rectifier, which means my components, I just put them in there. I don't cut the legs, bend the legs so that it can fit within how I've designed the circuit. Then here's another cardboard. Then I cut with respect to how my circuit looks like so that when I connect, then I don't have a problem with my connection. The same thing goes to this one here. I cut this one, which is a 3 cardboards. When you are done with this experiment, then you just take out your components, you put it aside, then you look at the next experiment. You just take your components, put it there. Remember, these drawings, at least they make life easier for you to understand exactly how your connection is supposed to be, or where your connection is supposed to be. Where you insert the component, take a piece of wire, connect where it's necessary very fast. Five minutes, you're done connecting. You're doing your measurements. 5 minutes, done connection. You're doing your measurements. 5 minutes, done your connection. You're doing your measurements, which means you spend 3 minutes measuring your circuit and also taking the photo with regard to whatever that you're doing, and also you're done with your writing of the values into your practical scope, practical diet. Okay, thank you very much. I'll see you soon in terms of looking at other experiments where you need assistance.